Okay. Then, Assalamu alaikum. Okay. Now, let's start. Last week we were checking some MCQs. Actually, I couldn't put this one, but the link in the groups. I already uploaded in the channel, but unfortunately, I think students wouldn't have received the link because you guys, everyone are not in the channel. Okay. Anyhow, just now I have uploaded the link. Mm, right. Now let's go certain questions related to uh, electronic configuration. Right. Today we'll see this part. Electronic configuration. Right. Under this one, okay. Uh, this is page number 14. Page number 14. Okay. Page number 14. And the first question. The electronic right. The electronic configuration, okay, of an atom with atomic number 35, right? Wait. Okay. The electronic configuration of an atom with atomic number 35 can be classified as, right. So when come to electronic configuration, chuttak, if we recall the things, right? If we recall the things, mm, there are mainly three rules related to this. Okay, mainly three rules related to this. Can someone tell who are the three people involved uh, related to electronic configuration? Yeah, but who are three people involved in electronic configuration? There are three people. Who are those three people? First one is, yeah, at least in the chat box. First person is Aufbau. Okay, Aufbau. What did he tell? Electrons will fill to minimize its energy. Okay, to minimize its energy. Electron fill in order to minimize its energy. So it fills from low energy to high energy. So Aufbau told like this, and he said a filling order. He said 1s. Again, second energy level, you have two subshells, 2s and 2p. And third energy level, you got three subshells, 3s, 3p, 3d. In the fourth energy level, it is 4s, 4p, 4d, and 4f. Normally, we speak these four things. In our syllabus, we are subjected to speak only about the fourth energy level, only up to the 5f 4b, right? Only about the 5f sub energy level, we are subjected to speak, right? So how you want to fill these electrons according to Aufbau? First one is will fill here, then second 2s will fill, third you have to come like this, 2p, then 3s, then I have to go from this part, 3p and 4s. So the next after 3s, 3p will fill. After 3p, 4s will fill first. After 4s only, this 3d get filled. Okay, 3d, 4p. Okay, this will be 3d and this will gonna be 4p and 4p. Okay, it gonna fill like this, 4p. Then after 4p only 4d will fill. Okay, so this is only according to Aufbau. Then the second person related to this is it is Hund. Okay, the second person related to this is Hund. Okay, what did Hund tell? He tell the electron First they will fill singly. After that only they will fill doubly. Okay, then only they started to get couples. And for an example, we'll say a p orbital. Just imagine p4. P4 mean 4 electrons in p. So how these 4 electrons will fill in p? First, these first, second, third. It will fill like this. Singly, first of all, it will fill. The fourth electron, then only it start to get couple. Okay, right. That is found. Then last person, Aufbau name. I'm sorry, Pauli. Then in Pauli, what did he tell? He told about the quantum number related to quantum number. He told an electron, okay, two electrons can't have the same quantum number. Okay, definitely they should have two different quantum numbers, right, related to that. Okay, so using this only now today, we are going to build up these things. Okay, all right. So let's go for the past papers again. Right, so this is the basic rule for today's discussion. Okay, right. Now, first thing they have asked the electronic configuration of an atom with atomic number 35 can be classified as 35. I mean, you have to write the electronic configuration. Okay, first you know one is, but you just write in this order. Just so whenever you are going to write this one, whenever you are going to write electronic configuration, first energy level only S, second energy level S, and second energy level you got P. Then you come to the third energy level. Third energy level, 3s is there, 3p is there, 3d is there, then 4s is there. Okay, so just come like this: 4s, 4p, 4d. Just write like this in order: 4d, first write up to this part. Okay, now 35, you have to fill 35 electrons here. 1 SK you can fill 2 electrons, 2 SK you can fill 2 electrons, 2, 4. Then PAK you can fill 6 electrons, then 10. SK you can fill 2 electrons, PAK you can fill 6 electrons. But you know, there is a special thing here, right? Special thing means like already you know that according to Aufbau you can see, right? After 3P, 3D won't fill. Actually 4S only will fill. Okay, you can see that. Okay, I'll show you again. According to Aufbau's principle, right? After the 3P, okay, 4S only should fill. After that only 3D will fill. Every time the corresponding D will fill, okay, after next energy levels S. Okay, it goes like that. Then come again to this part. Okay, so first of all, I have to put the two electrons of OS here. Okay, it means 2, 4, 10, 12, 18, 20. Now 20 electrons we have filled. Atomic number 35 mean, what does it mean? There are 35 electrons. So I have to fill up to 35. So I can fill up to 10 here now. Then I will get 30. Okay, if I fill up to here, I will get 30. So I need another 5 more. Okay, I need another 5 more. So I have to put 5 here. Then count and see, 35 will be okay. 4, 10, 12, 18, 28, 30, 35. All right. So here then 4D, I don't want to write, it's not necessary here. Okay. Now which one corresponds for this? S2P5. Okay, it is S2P5. So S2P5 mean it is on this fourth one. Okay. So that's how we have to select this answer. Then second one, the element with the atomic number 33 can be specified as. See, now you can see these are okay. Next questions related to this. Okay, so 33 mean I have to reduce 2 from this. 35 and 5 mean 33 mean up to here 13. Then it will come as S2P3. Okay, answer is third one. Okay, 33 mean S2P3. Okay. Now, third one, still you can't do this because we didn't do Lewis structures. We need the help of second unit to do the third one. But you should know what is the meaning of isoelectronic. Okay. Uh, no need to draw the Lewis structures. What we can go for this. Yeah. They have asked what is not isoelectronic only they have asked. Puta, you can use the periodic table to answer these questions. Huh? You can use periodic table to answer these questions. Now the first question is which of the following is not isoelectronic? What do you mean by isoelectronic? The meaning of isoelectronic? Isoelectronic. Iso mean same. Same number of electrons. That is only known as isoelectronic. Okay, which you have the same amount of electrons are known as isoelectronic. Good. Which of the following is not isoelectronic here only they have asked. Now not isoelectronic means first of all you see how many electrons are in carbon. Okay, it will zoom it. Okay, right. Now how many electrons are in carbon? Carbon, you got 6 electrons. Okay. How many electrons are in oxygen? 12. There is 8. 8 electrons in oxygen. So altogether 14 electrons in carbon monoxide. O2. O2 mean uh, oxygen. O2 you got 8 into 8, 16. N2. N2 you got 7 into 7, 14. Okay. Carbon here 6. Nitrogen 7 electrons. There is a minus sign. Minus mean you have minus 1 electron. 6 plus minus mean they have taken an electron, not minus. What do you mean by minus? The meaning of the minus charge mean they have taken an electron, therefore you have to add that. So this was equal to 14. Okay, now itself you can understand the answer. Okay, here 14, here 14, here 14 mean nitrogen here again 6, 7. Nitrogen is 7. Oxygen is 8. What do you mean by plus charge? They have lost an electron. 7 and 8, 15 minus 1, 14. So you can see which is not an isoelectronic killer they have asked. So answer is O2. O2 they have 16 electrons. All the other species they got 14 electrons. This is the meaning of isoelectronic. Okay. Now the fourth one. Okay. The fourth one. An element M forms a static M2 plus ion. The atom M and the ion have the same. What is same in this? Number of definitely M and M2 plus ions. M2 plus ions electrons become definitely different. Why? Because they have lost 2 electrons. Because if the electrons are same only, their chemical properties is gonna be same. Then what gonna be same now? Nuclear charge. Yeah. Nuclear charge only gonna be same because nuclear charge depends on number of protons. Because number of protons mean number of protons won't change because of the ion. Okay. All right. Who have done these questions already? Raise your hand. So we are done with these questions. Raise your hand. Already we did this. Is there someone? So already we did these questions. No. Good. Good. I mean, no, you have done right. So I have to give some time. Then I'll give some time to try these things. Uh, okay. Do question number 5. And this one, 6. 5 and 6. Okay. Now let's see. Fifth one. The electronic configuration of an atom X is, they have given like this, 4s2 4p3. The chemistry of X therefore likely to be similar of that. So S2p3 mean this belong to which group? S2p3 mean if you write like this, even you can count and see 2, 4, 10, 12, 18, 28, 30, 33. This is the 33rd element. So if this is the 33rd element, you can go and see the periodic table. What is the 33rd element? Okay. So when you see the periodic table, what is the 33rd element? What is 33? Yeah, you can tell. That you can type. One is active not today. So what is the 33rd element if you check in the periodic table? Yeah. Good. Okay. So 33rd element gonna be arsenic. Okay. It is arsenic. So arsenic belong to which group? It is 15th group. You can see the periodic table. If you see the periodic table, 1 minute. Okay. Now you can see this. You can see the 33rd element. So 33rd element is arsenic. So you can see arsenic in the arsenic row. What are the other things are there? Nitrogen, phosphorus, arsenic, antimony, bismuth. So all the chemical properties in the same group almost equal. The chemical properties of the same group are almost equal. So this should be definitely one of these: nitrogen, phosphorus, arsenic, antimony, bismuth. Right? Then we go to this question. So you got nitrogen here. So answer is nitrogen. Okay. Did you get the correct answer? Okay, good. Okay. Okay. Raise your hand if you have got the correct answer for this fifth one. Nitrogen killer. Who could decide that? Nitrogen. Hmm. Good. Hmm. Okay, fine. Nice. Now this is related to nitrogen. Now the next one. The fluoride ion has the same electronic structure as the fluoride mean F minus. Fluoride mean fluorine. Fluorine is in the 17th group, so it is F minus ion. So F minus ion has got 8 electrons. Okay, normally fluorine's place is 7th place. So 7th mean when they take 1 electron, they got 8 electrons. Okay, chloride ion means 17th. Cl minus. Chloride means Cl minus. So Cl minus will have 18 electrons. Oxygen atom will have 8 electrons. O2 minus ion will have 10 electrons. Okay, O2 minus will have 10 electrons. Neon atom, okay, neon, that also will have 8 electrons. Okay. Now, which has the now same electronic structure? Electronic structure means how the electrons are arranged. Now, oxygen have 8 electrons, atom, and also neon, they got 8 electrons. Therefore, the correct answer should be B and D. B, D mean 5 kilo we have to go. Okay, we have to go for 5. Okay. Fifth one we have to go as the option here. Okay. Now, next one. I'm sorry, 1 minute. We did a mistake. No? F minus is fluorine is eighth, right? Sorry, ninth. Ninth element only fluorine. It's in the 17th group, but in the ninth element, so there are 10 electrons. I'm sorry. Neon also they got 10 electrons. I'm sorry. Neon is 10 electrons. Neon atom is 10 electrons. So O2 minus also got 10 electrons. Neon also got 10 electrons. Then C and D only should be this one. So answer should be third one. I'm sorry. Third. Okay, fluorine is ninth, no? Not seven. Ninth. Okay, fluorine is 9 mean F minus will be 10. Therefore, O2 minus will have 10 electrons. Neon atom also having 10 electrons. Okay, so C and D answer is fifth one. Okay. First ionization we didn't do. Therefore, I'm not going to do that. Mm, okay, we'll do after completing the first ionization energy part. All right. Now you can try these questions. Okay, 8, 9, 10. Right, Karaganyam. 12th one. Tagal answer those 8, 9, 10, 11, 12. පුතා done until done කියලා. The message, send a message done. Hmm. Right. Now let's check this. The first thing is the element that shows the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Right. So count and see how many things are there, but you can directly, if you have very good experience, you can directly tell who is this element. But definitely this should be මොකද්ද කියලා එක direct, but better what you can do, you can see 2, 4, 10, 12, 18 and 18, 28, 29. Okay, so 29th element. So we'll see who is the 29th element here. So when you go to this, you can see the 29th element, uh, 29 or 30, I guess 30, no? Right, 30. 30th element is zinc. Okay, 30th element gonna be zinc. Okay, it's 4s1, no? 4s1 mean it is copper. I'm sorry, 4s1 mean it's 29, 29 mean copper. So you have to see for 29th element. That's it, not a big deal. Ninth one, the electronic configuration of atomic number 34 can be specified as 34. But the 34 mean, now normally I will tell this pattern using this periodic table. 34 mean, you can see this is this one, selenium. So selenium is fourth person in the P. You know this one is P block. Okay, you know this one. You know this one is P block element. This set is P block. So if this set is P block, you can see P1, P2, P3, P4. This is P4. No? Then this should come as P4. This is P4 because fourth one in the P. So P4 means we just don't write just P4, we write S2P4. Okay, so if it 34th one means it's supposed to be S2P4. No need to write from the beginning. You can see from the directly P block and you can decide that because this one is the fourth of P. This is the first one, this is the second one, this is the third one, this is the fourth one. This is the fourth element of P. That's why it comes under P4 category. So when you are writing this electronic configuration, we write S2P4. Okay. So the answer should be here as S2P4. Okay. So D10 S2P4 කියන එක තමයි correct answer කියලා we can accept. Other one, zinc 2 plus iron is isoelectronic with. Okay, zinc 2 plus iron mean, what do you mean by zinc 2 plus iron? Zinc mean zinc is losing 2 electrons. It means now zinc, you know, electronic configuration you see from the periodic table, it is 30. So if it lose 2 electrons, 30 minus 2, now it should have only 28 electrons. Now you have to say out of these people, how many who are having 28 electrons here, you have to see. It means you got nickel, you got arsenic, you got cobalt, you got selenium. Okay. Now we'll see who has 28 electrons. Now you can see cobalt is 27. So it won't match here. Okay. Then nickel, if you see, that is the 28th element. So 28th element means it has 28 electrons. Therefore, nickel is the good match for this. So I saw like nickel was there in the answer. So nickel should be the correct match. Okay, so easy. Right? Next one. O2 minus ion is isoelectronic with. O2 minus ion means oxygen is 8th one. So O2 minus means 10. It has 10 electrons. S2 minus mean sulfur is 16. 2 minus now they will have 8 electrons. Nitrogen is the seventh element, 3 minus 1, they will have 10 electrons. So definitely nitrogen is the answer. I think other thing that we'll see, I think lithium 3, 3 plus 1 mean this will have 2 electrons. Beryllium 2 plus mean that will also have 2 electrons. B3 plus mean that will also have 2 electrons. Look at these three having 2 electrons each. So answer is second one. The 12th one. The element with 1 electron in the outermost energy level. Okay, outermost energy level, there should be only 1 electron now. It should be a group 1 element out of group 1. So out of this, who is group 1? You can see CCM is a group 1 element. Okay, you can use the periodic table, no worries, right? You have the chance to use the periodic table. You can see how you can see in the first group CCM is here, then CCM is the answer. Because the first group people only having outermost shell, last electron. Only 1 electron is there only for these people. Alright, now we are with that. Okay, now you can try 13 to 17. 13, 14, 15, 16, 17. Try this. Okay. Right. Okay. Now, let's go with the questions. The electronic configuration of the element with the atomic number 48 can be specified as. Okay, now let's go for the 48. Now, this is a periodic table. If you come 48, you can see cadmium here. You can see cadmium. Okay, if you want, you can zoom it. So, this is cadmium. So, cadmium's position is here. So, this is D10, right? This shell is D10. When this one is D10, this, how we write it? S2 D10. It is S2 D10. Okay. Then this will be categorized under D10 category. Then if you come here, it's supposed to be D10. Okay. Now you have issue now D10 S2 or P6 D10. Okay. Now which one we have to select? D10 S2. Mean after S2 filled only this D10 will fill. Okay. And if P will fill, after P S only will fill. After S only D will fill. Okay, that's how it goes, right? PSD and it goes the way. It mean for an example, if 3P is here, after 3P 4S will fill, after 4S 3D will fill. This is the order. So you have to go with then which option? P6 D10 or D10 S2, right? Always we have to tell the last set of the electrons. Therefore, we have to go with D10 S2. Again, a last set. Here S is missing, so definitely S should be here. Okay, this should be here. P6 D10, but it's incomplete. So S2 also should come here. So D10 S2 is the correct answer. Who select this answer? D10 S10 की ने select कर बोगा? Raise your hand. Who selected D10 S10? Nice. Good. Okay. This the next part. The electronic configuration of molybdenum is 42. The outermost electronic configuration of molybdenum 3 plus ion is. So molybdenum is a special electronic configuration person. No special electronic configuration people. Okay, 24. I said few numbers 24, 29. And after that, 41 to 47, except 43. 41 to 47, except 43. So all these people are having a special electronic configuration. Okay, 24, 29, 41 to 47, except 43. Right. So now, if you go for molybdenum 42, molybdenum also having a special electronic configuration. So molybdenum, here can see on this part, there's molybdenum. 42 molybdenum. It will have the same chromium's electronic configuration, same chromium type. So chromium's electronic configuration type, it is S1D5. Okay, chromium is having S1D5. By normally S2D4 it's supposed to have, but chromium will take one electron from D. Therefore, it is having S1D5. So chromium, molybdenum both are having those patterns. So only chromium, molybdenum is included in our syllabus now, right? Tungsten is not there. W mean tungsten. Tungsten is normally tungsten they used to make our bulbs, filaments. They are tungsten. Alright. So that is not in our syllabus. So only we have to care about molybdenum. So S1 D5 is the answer. 5S1 for D5. Okay, that is the answer. S1 D5. The number of electrons in the outermost energy level of the di-positive cation, which is made from atomic number 29. Di-positive mean they should lose electron. 29 is actually copper. The copper 2 plus they are speaking. So 29 they lose 2 electrons mean. Now copper 2 plus when you write like this, they ask in the number of electrons in the outermost energy level. Okay. Now copper's electronic configuration. It is S1 D10 type. Okay, S1 D10, S1 D. These are after writing all these things, you will write for S1 3D10. Okay, so this is the electronic configuration they have. S1 for S1 3D10 electronic configuration. Then what will happen? They will lose 2 electrons. Then they will have for S1 will go. Then they will have now 3D9. 3D9. But in the outermost energy level like we got 3p6 is here, 3s2 is here. Okay, outermost energy level mean all the things with 3. Third energy level like the total number of electrons. So 3s2, 3p6, 3d9 mean add all these things. So answer will be 17. Okay, 9 and 6, 15 and 2, 17 electrons will be there in the outermost energy level. Like that's how you have to take it. Okay, okay. 13, 14, they ask molybdenum 3 plus. Very good. I'm sorry. They asked the molybdenum 3 plus, no? This is the molybdenum 45, 5s1. 3 plus mean they will lose 3 electrons. So it's gonna be 4d 3. Okay. So they will, when they lose 3 electrons, it's gonna be 4d 3, 5s not. Answer should be first one. Very good. I'm sorry. Okay, they have asked the molybdenum 3 plus ion. Good. And the 16th one. The atom that consists of only one electron in the outermost energy level, earlier question. The atom that consists of only one electron in the outermost energy level is chromium here. Why chromium? Chromium is, okay, it is 3d5 4s1. So outermost energy level means this fourth energy level. So fourth energy level is the outermost energy level. So there is only one electron here. Therefore, we have to go with chromium here. Right. Then the molecular formula of the hydride derived from the lowest oxidation state of the element M of the atomic number 34. So you don't have the idea of the oxidation states much yet, but let's see 34. What is the 34th element? It is selenium. So selenium in normally the lowest oxidation state related to oxygen and sulfur ඒක එච්චර we haven't done ඒක case එක. Oxidation state okay, normally selenium's valence is 2 normal or least condition oxygen it act like oxygen and sulfur. No, oxygen normally when you're writing compounds you write H2O, H2S, or never again you write either you write with valency 2. Same thing you have to apply here. Same thing like H2O, H2S, this will be H2SC, right? So metal hydride, lowest oxidation metal hydride will be uh, element M. Okay, element M. Hydride will be MH2. Okay, MH2 කියන එක තමයි we have to go for the option. Atomic number 34 is actually we have to write not MH2, H2M කියලා තමයි normally we write it. Right? Again, H2M M in the element M. Element M is 34 is selenium. Selenium is a non-metal. Normally when we are writing hydrogen and selenium, we write selenium second, hydrogen first. Okay, in a compound, normally whenever we are writing a compound or a least electronegative one first, most electronegative one second. Still we into the electronegativity also. The Etika we will do. The answer is this one. Eka further we'll explain later. Hurry. So with this we'll wind up the session. Okay, now till 26 A level batch finishes, we have to do this up to 8 o'clock. Hurry. After once they finish, we can extend it a bit. Okay. Okay. Now we'll wind up the session because using even although in a small amount of time, we did plenty of questions. Okay. We'll wind up.